Okay, engineers, now let's do one problem, one example. Now, this is the periodic function. The periodic function is a square function from minus pi to pi. Now, remember, these formulas has the constraint that it has to be from minus pi to pi, the periodic function. Okay, so it's a square function. It's going to be 1, and then minus 1, and then 1, and then minus 1, from minus pi to pi. Now, because of these formulas, all you have to pay attention is just in this region, from minus pi to pi. The rest, it doesn't matter, because it is actually repeated itself. Okay, now, here, an important concept. Now, pay attention to this. Is this an odd or even function? Well, it is actually an odd function. It is an odd function. Now, that is a very important thing because it's going to help us to calculate the coefficients. Now, why is an odd function? Because what happens in the positive side is on the contrary on the negative side according to the x. Now, another thing to see it is an odd function and a function impar is that if you make the reflection like this and then you make a reflection like this line covers this line exactly. Okay, so now let's calculate the coefficients. The coefficients is just to apply these formulas. So let's start with the first one. A0 is going to be the integral from minus pi to pi of the function f of x differential of x. Now, because f is an odd function, then the integral is going to be 0. Alright? So you don't have to calculate things. All you have to write me here is because it is odd function. Alright, and that's it. Equal to 0. Now, you can actually calculate that the result is going to be 0. Alright, then it's going to be, we have to split this integral in two, integral from minus pi to 0 of 1 differential of x plus the integral from 0 to 1, from 0 to pi, sorry, and in this region is going to be minus 1 here, differential of x. So it's going to be the integral of x is just x from minus pi to 0, and then minus, this minus goes here, x from 0 to pi, and then it's going to be 0 minus pi, minus pi, sorry. This evaluation, 0 minus pi, and then minus pi minus 0. So this is going to be plus pi, and then minus pi is equal to 0. Now, you made I did the calculation just to show you that actually it is equal to 0. We know it's going to be equal to 0 because it is an odd function. Okay, so I'm going to clear that part. This was just to show you. Okay, so 0. So that's why it was very important to know the concept of the odd and even function, because it's going to make your life easier. That only applies if the functions are even or odd. It could happen that it's neither of them. It's not odd or it's not even. So, for example, let's say that you have this function. It's not or not is not even. So ni es par ni es impar. So it's going to be helpful only if it is even or odd. Okay, now let's calculate an. No, an, sorry. An is going to be 1 over pi. Sorry, I forgot here it is 1 over 2 pi, the formula, for a0. For an is 1 over pi, the integral from minus pi to pi of the function f of x, and then the cosine of nx. Now, here, the concept. Now, f of x is an odd function. This one is an odd function, and the cosine is an even function. So the multiplication is going to be how much? Well, the multiplication of odd times even is going to be odd. Now, the integral of an odd function together is going to be actually 0. And that's it. So I'm not going to continue because it is actually 0. Okay, now, The only thing left is the calculation of Bn. Bn is equal to 1 over pi, this formula, the integral from minus pi to pi, the function f of x, the sine of nx, differential of x, and again, here is going to be, this one is odd, and this one is also odd. So the multiplication is going to be even, alright? So we do have a result here. So it's going to be 1 over pi. Because it is an even, I can do this 2 times the integral from 0 to pi, only one section because it is even function. So it's going to be f of x. From 0 to pi, how much is the value of the function? It's actually minus 1, and here 1. So it's going to be minus 1, the sine of nx, differential of x. So this is going to be equal to, the minus goes outside, minus 2 over pi, integral from 0 to pi of the sine of nx. We have to complete the integral, so here we need an n and then 1 over n here. So the Vn is equal to minus 2 over n pi here. Integral of the sine is the minus cosine, minus the cosine of nx from 0 to pi. So minus times minus 2 over n pi, and here the cosine of n pi minus the cosine of 0. Now the cosine of 0 happens to be just 1, and the cosine of n pi, according to the formulas that that I show you at the beginning of the course, the cosine of n pi is minus 1 to the power of n. Remember that the cosine of n pi is going to switch between positive 1, negative 1, positive 1, negative 1, and so on. Okay, so this is going to be 2 over n pi minus 1 to the power of n, and then minus 1. And this is the Bn coefficient. Okay, so we calculated the 3 coefficients. So the Fourier series of this function is going to be something like this. F of x is going to be a0 is 0, an is 0, so it's going to be just the summation of n equal to 1 to infinite, and here is going to be Bn 2 over n pi minus 1 to the power of n minus 1, and then the sine of nx. And this is the Fourier series of that periodic function. Now, if you want to develop, now this is actually the result, engineers. All you have to do is this. But if you want to develop this, all you have to do is to replace the value of n equal to 1 and then plus the value of n equal to 2 and so on. Okay, so let's do it just for practice. So n equal to 1 is going to be 2 over pi because n is equal to 1, and then 1 minus 1 to the power of 1 is going to be minus 1, minus 1 and minus 1, minus 2, the sine of x. So this is n equal to 1. And then plus, now let's do n equal to 2. So it's going to be 2 over n is equal to 2, 2 over 2 pi, okay, minus 1, because n is equal to 2, minus 1 squared is going to be positive 1, 1, minus 1, sine of 2x, because n is equal to 2. But what happens here? 1 minus 1 is equal to 0. Okay, so this coefficient actually doesn't exist. So on n equal to 2 is equal to 0. So it's going to be plus 0 on n equal to 2. So the next one is n equal to 3. So what happens with n equal to 3? So it's going to be 2 over 3 pi, and then here minus 1 to the power of 3 is going to be minus 1, minus 1 and minus 1, minus 2, sine of 3x. Okay, so that's n equal to 3. Now, n equal to 4, you can imagine that is going to be 0, and then n equal to 5. So it's going to be 2 over 5 pi, and then minus 2 here, sine of 5x. The next one is going to be 0, because it is going to be even. And the next one is going to be 2 over 7 pi, and then minus 2 here, sine of 7x. plus, and so on. Because this is going to go to the infinite. Alright, now, what happens on the plot? If you want to plot this, okay, what will happen is something like this. With n equal to 1, is going to be something like this. With n equal to 1, is going to be something like this. It's going to be close to this one. But with n equal to 3, with n equal to 3 is going to be something like this. So it's going to be closer to the periodic function. Now, with n equal to 7 or 8 is going to be something like this. So with more coefficients, the more convergence between the Fourier series to the periodic function. All right. Okay. So when is going to be exactly the same? When n goes to infinite. When you have infinite coefficients of periodic function. But the idea, engineers, here is to find what are the coefficients so that my Fourier series matches the periodic function. All right. Now, according to the periodic functions, the coefficients will be different. All right. Okay, next video we are going to do another example to show you this. All right. See you.